Alright, so we're going to be looking at area. And we're going to start with a square. And so remember that the way geometry students draw a square is with its characteristics. We know that a square has 4 right angles. And we know that a square has 4 congruent sides.
Okay, Mom, what?
Alright. So our square has 4 right angles, 4 congruent sides. And so therefore they, you know, a lot of times when they're marking the measurements of a square, they only mark one side because they expect you to know the other side, right? So if this side is 15 feet, that's going to be all they mark. But if you know it's a square, how much is this other side over here? It's also 15 feet because it's a square. And in a square, all the sides are congruent. So to find the area of the square, the formula that you usually see is s to the 2nd power, which means side times side. $15 squared. 15 times 15. So when you go to do it on your calculator, there are 2 different ways you could enter that. You could press 15 times 15, or you could press 15 and then you use your little button right there with the x to the squared power, and you would get 225. This is actually the reason that we call this little exponent here squared, right? The whole reason we call that squared is because it comes from the area of a square. And so the area of this side of this square would be 225 square feet. Alright, sometimes we are asked to work backwards. Okay? So sometimes they might say there is a square, and they might say the area equals 169 square feet. And it would say how long is each side. So then what it's saying is if the area is 169, it's saying 169 is equal to whatever the side length is squared. And so do you remember how do we undo a square? We do the square root. So we do the square root on this side and the square root on this side. So square and square root undo each other. S is by itself. When you're solving an equation and you get the variable by itself, that's the time to use your calculator. And so then you're going to do your square root sign right there. So it's going to be 2nd square root of 169. And we're going to get 13. So it means this side is 13 feet and this side is 13 feet.
Does that mean they're all 13 feet?
They would all be 13 feet, yes. All four would be 13. All right. So let's move on to some other shapes. So if we have a rectangle, now remember, every square is a rectangle, but not every rectangle is a square because not all four sides are equal, but the sides across from each other are equal. So these two opposite sides are equal and these two opposite sides are equal. And a rectangle does have four right angles. But if I'm looking at area, this side is 2 feet. I'm going to draw a dashed line there. So like this is 1 foot here and this is 1 foot here. 1 plus 1, 2 feet. And let's say going across here is 3 feet. So we want to know how many square feet covers this rectangle. Well, when you were in elementary school, you did problems like this and they just wanted you to count how many squares are in there. 6 square feet. So sometimes we put SQ with the feet instead of putting the little 2 on the exponent. But mathematically, how do you get that 6 without numbering all the squares? Do you see that it's just 2 times 3? So area of a rectangle, we say it's length times width, or you can say base times height. You might see either one of those formulas. And so when we say 6 square feet, what we're meaning is there would need to be 6 squares that are 1 foot by 1 foot, and we would need 6 of those squares to cover that rectangle. Right? It's going to cover it like the carpet covers the floor. Alright, so then we get into these other shapes. Like, what if I really did want to get carpet in this room? And you know what? I asked them about getting new carpet, and they're like, no, we're gonna move to a new school soon. You'll just have to put up with your ugly, dirty, ripped up carpet. Everybody who's here in class is looking at it like, yeah, Miss Collier, I never really looked at it, but it's pretty bad. Alright. So, if you haven't been in my classroom, kind of goes like this. As far as where the carpet goes. Because back here is a closet. My desk is right here, and all the students' desks are right in here. This is the door. But back here is a closet. You're not going to put any carpet right there because the closet is like all the way touching the floor. So if you wanted to know how much carpet we needed, you see that you can break this room down into 2 different rectangles. Some of you might see it broken down this way. Some of you might see it broken down this way. You could do it either way. I'm going to break it down like this. Alright, and I'm going to use some color coding here. If you are a person where color coding makes sense to you and helps you understand, you might want to grab a colored pencil or even shade with your regular pencil. So this classroom floor is really made up of 2 rectangles. Right? So I have a larger orange rectangle, and then I have a smaller black rectangle. So if I need to know the total area, if I need to know how much carpet, I'm going to find the area of the big orange rectangle, and I'm going to add it with the area of the little black rectangle. So we call this composition, composite area. That prefix co, remember, means together, like cooperate. It means we're going to put these two areas together, make a composite figure. So we find the area of one, we find the area of the other, and we add them together. Alright, so the area of the orange, do you agree that that would be 10 feet for this side and 12 feet for this side? So that would be 10 feet multiplied by 12 feet, which would be 120 square feet. Alright, but what about this black rectangle? Alright, well, let's think about this side here first. I need to know how long this little line segment is. You remember in the very beginning of the year we did something called segment addition. So all the way from this dot to this dot is 15 feet. And I know from this middle dot here is 12 feet. How would I find that missing black part? I would subtract, right? I would do 15 subtract 12 equals 3 feet. So this little black part right here is 3 feet. Take the whole thing, take away the orange, you have that little black part left. Oh, now I need to find this part. Do you see that you don't even have enough information to find that right now? But what if I came in here and told you that this closet was 2 feet? Now how much is this black part? How much? Say it louder. 8. How'd you get the 8? 10 minus 2. Right? All the way across is 10. The closet is 2, so this part right here is 8 feet. So now the rectangle, the little black rectangle, is going to be 8 feet times 3 feet. So 8 times 3 is 24. And then we add those two together. 120 added with 24 would give us 144 square feet. And when you buy carpet, you pay for it by the square foot. So then if you needed to figure out the price of to do the carpet, you'd take 144 square feet and then you'd times it by the price per square foot. Okay, so we've done squares and rectangles and now a shape that was 2 rectangles added together. Now we're going to move on to a triangle. So our formula for the area of a triangle is 1/2 base times height. So in this picture, I want you to understand where this formula comes from. If I take this triangle here, kind of shade it in, and I reflect it, I flip it over, do you see that the two triangles together would make a rectangle? And so my area of my rectangle is base times height, but my triangle is only half of that rectangle. So that's where this formula comes from. Every triangle is half of some rectangle. So basically the formula is saying find the area of the rectangle and then cut it in half to get the triangle. Alright, so if I take this triangle right here, and notice this guy is a right triangle, and so this would be my base. Let's say my base is 7 and my height is 9. So then I would say my area is 1/2 times 7 times 9. So my calculator, I can do 1/2, I can do 1 divided by 2 for a half, times 7 times 9. Or instead of a half, I could put 0.5, right? Because that's equivalent to a half. So I could put 0.5 times 7 times 9. So 31.5 square feet. If I was in feet. I didn't write down any units. So we'll just write 31.5. Well, sometimes the area of your triangle can be a little bit trickier than that. Let's look at this triangle. So the area of the triangle is 1/2 the base times the height. But if you do 1/2 5 times 6, you'll be wrong. So think about this a minute. If you want to see how tall you are, do you stand slanted like this? Or when you measure your height, do you stand straight up? This right here is the height of the triangle. This is the height. This 5 is not the height. You're like, well, Miss Collier, that one doesn't have a number on it. So we're going to have to figure that number out, because we know all about triangles now, correct? If this is a height, it's going to make a right angle, correct? And if this comes down for a right angle and splits this into 2 equal parts, if all the way across is 6, how much is this half? 3. And now if I just look at this orange part, can I do the Pythagorean theorem with that guy? Right? You remember the Pythagorean theorem? A squared plus b squared equals c squared. Across from your right angle is the hypotenuse. The hypotenuse is equal to c on the Pythagorean theorem. So I'm going to let this 3, and I'm going to say this is b. So I'm going to say 3 squared plus b squared equals 5 squared. 3 squared is 9. 5 squared is 25. Then I'm going to subtract the 9. B squared is 16. And then I need to do the square root. So I know it by heart because I know my times tables, but if not, you would press square root of 16. And it's 4, because 4 times 4 is 16. So the height of this triangle is 4. That's the height. So now I want the area of the whole triangle. So that's 1/2 times this whole base here, which is 6, times the height of the triangle, which is 4. And so I do 1/2 times 6 times 4, 12. And we'll just put square feet. We'll assume we're measuring in feet. Now, this is one where you don't need a calculator. You can do some mental math. What's half of 6? 3. And what's 3 times 4? 12. Right? So that one you could do even without a calculator.
Would it go the other way?
What do you mean?
You do the 4 first and then 6.
Yes. So then what's half of 4?
2.
2. And what's 2 times 6?
12.
Yes. Because we're doing multiplication, multiplication can go in any order. That's a very good point, William. Because sometimes this number over here is easier to take half of. Alright. So let's look at, what if we had a shape that had a rectangle and a triangle inside of it or connected to it, right? So let's look at this design. Alright, so take a minute to sketch this. Put your measurements on there. So the first thing is, can you see the picture of it? Can you see that we would do the area of a rectangle, and then we would add that with the area of the triangle? Do you see that it's two shapes put together? Alright. I'm going to color code them. If that helps you, you can do that too, but you don't have to. So everything on my rectangle is going to be one color. And then everything on my triangle is going to be another color. Okay, so for the area of the rectangle, that's the length of my rectangle. So from this point to this point, that's 9 feet. And from this point to this point, that's 4 feet. So area of a rectangle is just 9 feet times 4 feet. Do y'all know how to do the 9 times tables in your hands? Anybody ever teach you that? So 9 times 4. Watch this. 1, 2, 3, 4. Put this finger down. 36. This is your tens place. 1, 2, 3. 36. You want to do 9 times 5? 1, 2, 3, 4, 5. Put this thumb down. 45. You want to do 9 times 7? 1, 2, 3, 4, 5, 6, 7. Put this finger down. 63. You want to do 9 times 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Put this finger down. 81. So if you didn't know that, now you know. You don't ever need a calculator for your 9 times tables. So that's 36 square feet. Okay, now our triangle, remember the formula for a triangle is 1/2 the base times the height. So we're going to do 1/2. So what is the base of this triangle? Well, this base of this triangle is the same as this side of the rectangle, right? So that's going to be 4 feet. And do you see that this is the height of the triangle here? Not this slanty part. This is the height. But how tall is it? How are you going to get it? 13, take away 9. So how tall is that triangle? 4 feet. So you can type all this in your calculator, or you can do mental math. What's half of 4?
2.
And what's 2 times 4?
8.
And then you add the area of the rectangle and the area of the triangle together.